If you're like me, whenever you need a battery or two for a TV remote or a game, instead of just buying one pack of 4 batteries, you go to a giant box store and get a pack of 20. Then, the next time, you forget that you bought that pack of 20 and run out to the store and get a pack of 4. Since you only needed 2, you now have 22 batteries. You do that enough times now, you realize you're losing your mind. But you also have a battery collection that rivals Tesla. What do you do about it? You use Autodesk Inventor to design a battery storage box where you can put the batteries you have in a convenient location. In this video, we're going to look at using an Excel spreadsheet inside of Autodesk Inventor to create a spreadsheet-driven part that allows us to specify storage space for AAA, AA, C, D, and 9-volt batteries. Hi, I'm Stephen Shane, aka the 3D Professor, and this is the 3D Professor's Lab. I'm going to start out by setting up the spreadsheet. I'm going to use the spreadsheet to drive all the components of the part, starting with adding a table and titles: battery, diameter, length, width, and height. I will fill these in so I have complete headings. I'm also going to set up a gap parameter. The gap will be the space around the battery. This project will be for battery storage meant to hold AAA, AA, C, D, and 9-volt. The gap will be the space around the battery, so the battery fits more easily after it's 3D printed. I will start with AAA. The diameter is 10.5 millimeters, and the length is 44.5 millimeters. I can use the height as the height of the battery. So I'll set the height to 44.5 millimeters. And the gap is going to be 0.8 millimeters. Now I'll add the parameters for AA, C, D, and 9-volt batteries. Now that I have the table set up for the size of each battery, along with the gap and the space, it's time to set up the parameters that will be used inside of Autodesk Inventor. One thing that's important to keep in mind is Autodesk Inventor cannot use a table like I have in rows 1 through 6 as parameters. Each parameter must be a separate line and has a parameter name, a value, and units. Starting at row 8, I'll add headers for the 3 parameter columns. Row 9 will be the start of the parameters. This is important to remember when I link the spreadsheet. I'll enter the parameter name. In this case, AAA underscore diameter. Enter the value. I'm going to use the table above for the values. Now I'll use the table to complete the parameters and values. Then add the units afterwards. Once I add the gap and space values, I'm going to set up parameters for the number of columns for each of the batteries. This way, if I want to add additional columns into the design, all I must do is update the number of columns in the spreadsheet for that battery type. Now that I have the initial parameters set up, I'll enter the units, millimeters for all the dimensions, and UL for all the count values. While this completes most of the parameters, I want to set up additional parameters that use more complicated formulas to get the overall box size, calculating the width, depth, and height based on the number of batteries the box will hold. I'll add a total number of battery slots just using a sum of the numbers for the 5 battery types. The height of the box will be driven by the number of AA batteries per column. If I want 10 batteries, 12 batteries, or 15 batteries per AA column, the height will change accordingly. Next, I'll set up formulas for calculating the size of the overall box, starting with box width. This is going to be in millimeters, and the formula will use the diameter of each battery and the length of the 9-volt battery. Those values will be multiplied by the number of columns for each battery type. The gap will also be included and multiplied by the battery total. The space value will also be multiplied by the battery total. And lastly, an additional space will be added to provide the last wall of the box, providing an overall width. For the box depth, I'll use the height of the D battery along with the gap and the space times 2 for the front and back walls, making sure to include the units. For the box height, I'm going to take the AA diameter and multiply it by the AA quantity, adding an extra space for room at the top. With the formulas in place, changing the number of battery columns, I can change the box width. Now I'll switch over to Autodesk Inventor and we can create the battery storage box. I've already set up a battery storage part file and saved it in the same location as the spreadsheet. You don't have to do this, but it makes it a little easier for managing your files, at least when you have one spreadsheet and one part file. On the Tools tab, I'll open the Document Settings, Units tab, and make sure the unit's length is set to millimeters. Then I'll close the dialog. On the Manage tab, I'm going to open the Parameters dialog. Once the dialog opens, in the bottom left, I'll click Link. In the dialog, I'll select the battery_sizes.xlsx file. There are two options. You can either link the file or embed the file. Linking the file keeps the Excel file editable outside of Autodesk Inventor. And when you open the part file using that spreadsheet, it will check to see if the link has been updated. If you embed the spreadsheet, you can edit the spreadsheet only from this Inventor file. In this case, I'm going to keep it linked. The other thing that's very important is to use the right start cell. Remember that I created the top of the spreadsheet as a table, and the parameters do not start until row 9. If I leave the start cell as A1, I'll end up getting an error. I'll change the start cell to A9 and click Open. I made a few additions to the spreadsheet before I started working on the Inventor file to add start values for the first rectangle of each battery column. Now I can reference any of these values as I start my design. I'll start by creating a new sketch and picking one of the planes. With the sketch panel active, I'll create a rectangle. Click on the Dimension tool. I'll dimension the width, picking the left side, then the right side. Clicking to place the dimension, and clicking on the check to close it. I'll leave the dimension value alone for now. I'll do the same thing for the height, picking the top edge and the bottom edge, placing the dimension, and accepting the dimension value. Before I change the dimension values for the width and the depth, I have a habit of locating my initial sketch. I'm going to add 2 more dimensions that will center the rectangle around the origin. I'll add a dimension from the top edge to the origin point. Click to place the dimension. Then in the formula, choose the depth dimension and divide that by 2. Doing the same thing horizontally, I'll place the dimension from the left edge to the origin point. Click to place the dimension, then set the value to the width dimension divided by 2. I'll double-click on the width dimension. I can either right-click or click the arrow to the right and choose List Parameters. Then pick Box Width from the parameters list. Close the list and accept the value. Now I've got to zoom out a little bit. Double-clicking on the depth dimension, I'll list the parameters and choose box depth, then accept the dimension. I'll finish the sketch and add an extrusion using the rectangular profile. In the distance, I'll open the parameters list and choose box height, then click OK. Next is to start creating the slots for the batteries. I'll begin by creating a new sketch on the top of the box. I'll start by making a rectangle for the AAA batteries. I'll start a rectangle just off the inside of the left edge and drag down to about here. Then I'll create a smaller rectangle that's going to be used for the opening in the front of the box so I can see how many batteries I have. And this one's going to go from just about here on the front edge of the rectangle for the battery to the front edge of the overall box, making sure the rectangle is constrained to those edges. Selecting dimension, I'll set the dimension from the left edge of the rectangle to the edge of the box, selecting a parameter called space. Then I'll dimension from the front edge of the rectangle to the outer edge of the box, and just pick the first dimension as a reference. Selecting the top edge, I'll add a dimension that uses the AAA_diameter parameter and adding it to the gap parameter. So the formula looks like AAA_diameter plus gap. I'll select the side edge for the length of the rectangle. From the parameters list, I'll pick AAA_height and add gap to that as well, making it AAA_height plus gap. Lastly, I'll add dimensions that go from the right edge of the opening to the right edge of the battery rectangle. Set the value to 3 millimeters. I'll do the same thing on the other edge, selecting the edge of the opening and the edge of the battery rectangle, and set that value to use the first 3 millimeter dimension. That way they're always the same. Now that I have it fully dimensioned, I'll finish the sketch. On the 3D Model tab, I'll add an extrude. Pick the two profiles, one for the battery and one for the opening. And in the distance A entry, I'm going to set the value to box_height minus space. This will give me a floor at the bottom of the box, the thickness of the space value, in this case 2 millimeters. I'll make sure the Boolean is set to cut and the direction is correct. For the bottoms of each of these slots, I want to create a fillet on the sides and the back. On the Modify panel, I'll click Fillet, zoom in to get a better view of the bottom inside of the first battery slot, and pick the 3 edges that make up the bottom. In the formula, I'll click the right arrow and list the parameters, and pick AAA_diameter and divide that by 2. Then accept the fillet. I want to make a rectangular pattern using the extrusion and the fillet. From the pattern panel, I'll click Rectangular Pattern. For the features, I'll pick the extrusion for the first battery and the fillet. For direction 1, I'll click the top front edge. And in the count value, I'll select from the list of parameters the num_AAA parameter. For the distance, I want to use the AAA_diameter parameter and add to that the gap and the space parameter. So the formula will look like AAA_diameter plus gap plus space. Then I'll click OK to accept the values and create the pattern. Next is to repeat the same process for the AA battery slots. I'll select the top face of the box and create a new sketch. On the Sketch tab, Create panel, I'll click Rectangle and create a rectangle to the right of the last AAA battery slot. Then I'll create another rectangle from the front edge of the battery rectangle to the front edge of the box, making sure the rectangle is constrained to both. I'll select the Dimension tool. Then I'll pick the left edge of the battery rectangle and set a dimension to the left edge of the box. One of the changes I made to the spreadsheet was to add a starting point for the next size battery from the left edge of the box. When editing the dimension, I'll open the parameters list and choose AA_start and accept the value. This value in the spreadsheet considers the number of AAA batteries, the gaps and the spaces for the starting point of the AA batteries. I've also done this for the C-size battery, the D-size battery, and the 9-volt battery columns. For the width dimension, I'll choose the parameters list and use the AA_diameter plus gap as the formula and accept the dimension value. For the length dimension, I'll choose the parameters list and set the formula to AA_height plus gap and accept the dimension value. I'll dimension from the left side of the smaller rectangle to the battery rectangle left edge and set the value to 3 millimeters. Then create a dimension from the right edge of the opening to the right edge of the battery and pick the first 3 millimeter dimension. That completes the offset and the battery size, so I'll finish the sketch. In the 3D Modeling tab, I'll click on Extrude and pick the profile for the AA battery and the front opening. Make sure the Boolean is set to cut, the direction is correct, and the distance A value is set to box_height minus space, and click OK to create the cutout. Again, I'll select Fillet, choose the 3 edges at the bottom of the AA battery slot. For the radius value, I'll choose the AA_diameter parameter, then divide that by 2. Once I'm done, I'll accept the values and close the dialog. Again, I'll create a rectangular pattern. This time, I'll choose the extrusion for the AA battery slot and the fillet for the bottom of the AA battery slot as the features. I'll click on the direction and select the top front edge of the box. In the count value, I'll use the num_AA parameter. And in the distance, I'll set the value using the AA diameter parameter plus the gap plus the space parameters. And click OK to accept the pattern. Since the rest of the battery slots are the same, I'm going to speed this up a little bit and finish off creating the battery slots. I'm going to make one last modification to the front of the battery box and add a space at the bottom where I can pull each battery out. I'm going to speed this up a little bit, but essentially what I'm going to do is create a series of rectangles that will be the size of each battery plus the space, and it will cover the distance of each set of battery slots. Once I create the rectangles, I'll go ahead and extrude that back and use the space parameter as the distance value. The dimensions will be pulled directly from the spreadsheet, so these will adjust when the parameters in the spreadsheet change. That finishes the overall design of the box. I'll go ahead and open the spreadsheet and make a change to the number of battery slots for the AA batteries and set the number of slots to 4 instead of 3. I'll be sure to save the file. When I jump back into Inventor, notice that the local update icon shows a lightning bolt, indicating that something needs to be updated. By clicking the icon, I'll update the Inventor file from the spreadsheet. Notice that everything changes to accommodate the additional battery slot. I'll jump back into the spreadsheet and change the number of AA battery slots back to 3 and the number of C-size slots to 2, and be sure to save the file. When I go back into Inventor and update the part file, there are now 3 AA battery slots and 2 C-size battery slots, and everything updates as needed. Before I print the part, I'll reset the number of C-size battery slots to 1, then jump back into Inventor and update the file. I'll resave the Inventor part file, and then save it as an STL file and 3D print it. Once it's been printed, I can finally organize all my batteries. Now I finally have a place to organize my batteries, and not just in a basket in a cabinet in my dining room. Thank you for watching. If you like this video, please click the like button and subscribe to my channel. I'm Stephen Shane, the 3D Professor, and it's time to go home.